Hello everyone. So today we are going to see how to solve this particular question. So here you can see that this is the problem statement. How many integers between 1 and 200 are divisible by at least one of the integers 2, 3 and 5? So in order to solve this problem, we are going to use something called as principle of inclusion and exclusion. So let's see how we are going to go about this. So I've just written the calculations ahead of time to save some time and so that the video shouldn't become unnecessarily long. So what we are going to do, first we are going to count the multiples of each number. So which number am I talking about? I'm talking about these numbers, 2, 3 and 5. So first of all, what we'll do, we will count the multiples of 2. Okay. So multiples of 2, what they are 2, 4, 6 and so on all the way up to 200, right? Remember, we are looking at numbers between 1 to 200. Now this is an arithmetic sequence where the first term is a equals to 2 and the last term is L is equal to 200 and the common difference is D is equal to 2. So the number of terms N can be found out by using this formula. Which formula? N is equal to L minus A upon D plus 1. So here we are calculating 200 minus 2 divided by 2 plus 1. This will give us 100. See, 200 minus 2 is 198 divided by 2, okay, which is equal to 99, and plus 1 will give us 100. So in short, there are 100 such terms which are 100 numbers which are multiples of 2 between 1 to 200. Okay, now let us go to the next one where we are going to count the multiples of 3. So for this, we are looking once again between 1 to 200 and the numbers are 3, 6, 9 and so on up to 198, right? Okay, so here the first term A is 3, then the last term L is 198 and the common difference is 3. So once again, we are going to use the formula which we used earlier. So L minus A upon this one, this is the formula that we used. L minus A upon D plus 1. So 198 minus 3. So 195 divided by 3, that is 65 plus 1, that gives us 66. Likewise, we will proceed ahead. We will find out or count how many numbers are there which are multiples of 5. So between 1 to 200, we are starting with the first number 5, then 10, 15 and 200. So the first number is 5, the last number is 200, the common difference is 5. And once again, we are going to use the earlier formula and this is what we get, that there are 40 numbers which are multiples of 5. So far we have got 100, 66 and 40. Okay, now we are going to count the terms which are multiples of 6, that means 2 and 3. So that means now what are we looking at? We are looking at the combinations. Like we have 3 numbers, just I'll write over here, 2, 3, 5. These are the ones that we are looking at. So now we are looking at the combinations. So what are the combinations? Like 2, 3, then 3, 5, and then again we are going to look at 2 and 5. And also lastly, we are going to see all of them together. That means 2, 3, 5 combined. That is also going to be one combination. So here we are now going to look at multiples of 6 because 2 into 3 is equal to 6. So between 1 to 200, the numbers will be 6, 12, then after that 18 and 198. So the first number is 6, last number is 198, the common difference is 6. So once again, we'll use the earlier formula, that is L minus A divided by D. So 192, this will give us divided by 6 plus 1. So 32 plus 1 is 33. Now we'll see the next one. And next one is multiples of 10. That means the combination of 2 and 5. So multiples of 10 will be between 1 to 210, 20, 30, up to 200. So first term is 10, last term is 200. The common difference is 10. And once again, we are going to calculate the number of terms by making use of this formula. So 200 minus 10 divided by 10, right? So 190 divided by 10, 19 plus 1, that will give us 20. And now we'll come to the third combination, which is multiples of 15, that means 3 and 5. So the multiples of 15 between 1 and 200, starting with 15, then 30, 45, and last one is 195. So the first number is 15, last number is 195. The common difference is 15. So once again, we use our earlier formula, 195 minus 15, that is 180 divided by 15, that is 12 plus 1, which gives us 30. And now we are going to see multiples of 2, 3, and 5. That means 2 into 3 is 6, right? 2 into 3 into 5, 15 into 2, that is 30. So we are going to see the multiples of 30. So starting with 30, 60, 90, up to 180. So first term is 30, last term is 180, common difference is 30. So once again, we use our earlier formula, 180 minus 30, 150 divided by 30, right? That is 6 plus 1 equals to 7. So now we have got all the possible combinations and the multiples. So what we are going to do now, it is time to apply the inclusion exclusion principle. So with that, we can find out the total count. So let us see how we are going to apply the inclusion exclusion principle. So this is the total count. So first of all, we have multiples of 2, multiples of 3, multiples of 5. We are going to add them. And then we are going to subtract the common ones, which is multiples of 2 and 3, 2 and 5, all the combinations, 3 and 5. And then we are going to add the multiples of 2, 3, and 5. Okay, this is the formula which we have to use. Just keep that in mind. So now, substituting all the values that we had found out earlier in our calculations, here you can see all these numbers. We are going to add and subtract, and this gives us this number 147. So what is our answer finally? That the number of integers between 1 and 000 that are divisible by either 2, 3, or 5 is 147. You can try this same problem using some different combination of numbers as a practice. Thank you.